Welcome. In this video we are talking about the Linux boot process. You hit the power on button, what happens behind the scenes? So this entire video is dedicated to understanding those steps. So initially, you hit the power button. It goes through its BIOS, basic input output systems. It will execute the MBR. The MBR is called the master boot record. MBR will execute Grub. Grub is the Grand Unified Bootloader. Grub will execute the kernel. The kernel will execute the initial content located in the sbin / int area. The int area will actually then execute run level programs. The run level programs will actually then execute additional content from the RC directories. So let's go through that a little bit slower. So you hit the power button, it will go through the BIOS. This will perform some system integrity checking. It will search, load, and execute the bootloader program. That's going to be located with the MBR. It looks for bootloaders like in the floppy, in a optical drive, and the hard drive. This is also typically where you can enter the system's BIOS with like an F2 or delete option. Once the bootloader program is detected and loaded into memory, BIOS will give control to it. And again, that's going to be BIOS loading, finding the bootloader, and then handing it over to the master boot record. So, the master boot record is going to be located in the first sector of the bootable disk. Typically, it's found in the dev HDA or the dev SDA, depending if it's a hard disk or a SATA, or not a SATA, an SSD. The MBR is typically less than 512 bytes in size. It has three main components. It has a bootloader. This is going to be the first 446 bytes. The second partition table will be in the info. It will be in the next 64 bytes. And third, the MBR validation check in the last 2 bytes. All of this combined will allow the Grub, if it's a newer system, ILO, if it's an older system, to be found and executed. And again, the MBR will hand out all of this to the Grub bootloader. Grub is again the Grand Unified Bootloader. If you have multiple kernel images installed on the system, you can choose which one to be executed. Grub will display a splash screen for a few seconds for you to determine which configuration you actually want to load. The Grub configuration is typically located in boot grub, grub.config. However, you can also find it underneath etc grub config. However, the etc grub config actually is linked back to the boot grub config. And again, once this loads, Grub will load and then execute, and then hand it off to the kernel to the next portion of the process. The kernel will actually execute anything in the sbin int program area. Since the int was the first program to be executed by the kernel, it should have the process ID PID of 1. You can do a ps tac ef grep int and check the PID if you want to know. So actually that's what I'm going to do. I'm going to open up my terminal. I'm going to do a ps tac ef. I'm going to pipe in grep init. And it has a PID of 1. Something to note is the INRD stands for the initial RAM disk. The initial RAM disk is used by the kernel as temporary root file systems until the kernel is fully booted and the real root file system is mounted. It also contains the necessary drivers compiled inside, allowing and aiding in accessing the hard drive's partition as well as other hardware. So the INT will actually look at the etc INT tab file to decide which run level should be followed. So there are 7 main run levels, 0 being halt, 1 being single user mode, 2 being multi-user mode without NFS, 3 being full multi-user mode, 4 is unused, 5 is X11, and 6 is reboot. So the INT will identify the default initial level from the, again, ITC int tab, and will use this to load all of the appropriate programs. We can execute a grep init def etc int tab on our system to identify the default run levels if we wanted to. The last thing is our run level program. We have run levels 0 through 6, so there are 7 of them. All of them will be located in the etc rc.d level. There's going to be an rc0.d, rc1.d, and so forth. So to go ahead and point this out, I'm going to open up a file browser. I'm going to go to Computer, File System, etc, and I actually want to go down to where all of the RCs are. And you'll see, instead of having rc.d, Kali actually has rc0.d, rc1.d in its etc folder. And again, there are 7 of them, 0 through 6. And they are different files, different daemons, and different content based off of what needs to run. So do keep in mind there are symbolic links in some of this content. So as we're looking at them, the location may not be their true location. And in a nutshell, these are the steps required by Linux to boot. Questions or concerns? Reach out.